In this video, we're going to look at how to use TopSpin to process NMR spectra. So you'll have to have TopSpin downloaded on your computer. As the link on Blackboard explains, that this is available for free. It can take a little while to download, so you do need to be patient, but overall it works well. If you don't download it on your computer, you can always, with my assistance, go to the NMR lab and process it on your own in the NMR lab. If you need help processing, you can always reach out to me. Come to office hours. I can work with you to do that. And I should mention, there are other free NMR processing programs available. So if you're looking for a suggestion of whether something that you found is appropriate for our class, you can let me know. But most of the processing we're doing is generally pretty simple. Predominantly, we're just going to be um, picking peaks, so finding the chemical shifts, and then the integrations. So what I've done here is I've pulled up a NMR spectrum, a proton NMR spectrum for ammonia borane, which is something that you will be preparing in the course. Now, I have it set up in my TopSpin that I have a drive or a folder on my computer that has all my NMR files, and so I can pull it up through this window on the left-hand side, this browser window. You don't need to do it that way. What you could do is if you can go up to here under the Start tab, Open Data Set, and you can search for it manually that way. Okay, but either way, what you're going to want to do is you're going to pull it up, and usually the way these folders are is you'll have the folder with how you saved it. And in this case, there's both a proton spectrum and a boron spectrum. So those are two different folders. You can double click, it'll open the folder, and then we want to make sure that we load that file there, number one. When the program processes it after it runs the spectrum, a lot of times it'll put in peaks or integrations on its own, and those often aren't very accurate. So we're going to want to do that manually. So some of the things that we're going to want to do is really before we do anything, we want to make sure that we reference our NMR spectrum. Generally, depending on the lock of the instrument, the magnetic field, you can have your peak shifts can be a little bit different from maybe what someone else used on their NMR spectrometer. So we always reference it. And generally what we do is we reference it to the proteo portion of the deuterated solvent. So we use deuterated solvents, but there's always a small percentage of partially proteated version of that solvent in your sample, and so that's going to provide the shift that we're going to reference, and those can be looked up. In our class, we're predominantly using chloroform, which we can reference at 7.26 ppm, or DMSO, which references at 2.50 ppm. In this particular spectrum, we're using DMSO. So usually what I do is I find a peak here that shows up around 2.5. Okay, and that's going to be my my solvent peak. So what I'm going to do is we can zoom in a little bit, and I can do that by just sort of clicking and dragging. And it'll let me zoom in on that portion. Then what I can do is go to Process up here, and I can go to Calibrate Axis. So if I click on that, it's going to pull up this line. Now I'm going to put it right at the top of that line, and I am going to type in 2.50 because it's DMSO, and that's where I know it should be referenced. Okay, and that's going to fix that for me. If I use this button right here, this will show the full spectrum again. And I'm going to, again, focus in and zoom in at a particular region. What I want to do next is I want to pick my peaks. And so we can do that under the process. If we go to pick peaks, it's going to pull up this window. And this appears to be sort of the default, and there's a lot of extra peaks here. So what we can do is we can delete all peaks, and then we can do it manually. And so the way we can do that, there's a couple ways to select, but if I click on this right here, then I can drag what I want it to select. And it's not necessary. This DMSO peak is at a much higher intensity. We don't necessarily need to select that. But what I'm going to do is I'm going to click and hold. And then by doing that, right, sort of highlighting where I want it to select, it's going to pick the peaks. Okay, and so that tells me where my peaks are. Just as a reference, this peak around 3.3, that's water, and that's common to have in our NMR solvent. This over here, this peak around 4.4, that's going to correspond to the NH3 peak of the ammonia borane. And then this broad peak here, and something that we talk about in the lab, is actually the BH3 peak. So they're quite broad. I can use my scroll on my mouse to increase the intensity. Okay, so if I do that, and then I click on this, it'll save it for me. Next thing I want to do is I want to look at the integrations. Okay, if this is my NH3 and this is my BH3, they should integrate about one a piece. So if I go to integrate, again, I'm going to want to clear out all the integrals that have been done by default and do it manually. And so in this version, sometimes you'll see a couple different versions. One of the things is it doesn't always, essentially there's usually two options. Okay, and for whatever reason, my version doesn't have this, but one of the options is I could just delete everything. For whatever reason, my version does not have that button there. So what I need to do instead is I need to go ahead and select my integrals manually to get rid of them. So it's a little bit more tedious if there's a lot of them. But like I said, there is sometimes in some versions of this software, there is a button that lets you delete all of them right off the bat. Okay, so now that I have this here highlighted, so this is the select region, I can then go through and I can integrate them. One thing to keep in mind, this is a common mistake, is if you want, let's say you want to zoom in on a peak to get a more accurate integral, make sure that you deselect that, because otherwise whatever you select is going to be integrated as opposed to just zoomed in, right? So if I want to zoom in here, I can do that. But if I had this selected, it would integrate that. So let me see if it'll let me go back. It doesn't let me redo the zoom. So let me go back here. Again, we don't need that. And I guess I forgot to delete that integral. So let me go ahead and do that. Okay. All right, so I'm gonna go ahead and integrate, and all we really need to integrate are the peaks that are for our compound or any impurity. So I take this, and you want to make sure that you're not integrating it where the peak starts going up. You also don't want to start way far away from the peak because then you're going to get some baseline as well. So you want to get kind of close to just before it starts increasing. Let me actually redo that. For whatever reason, it started moving my thing around here. But I do that. Okay, and there's that integration. So that's worth one. Usually it'll, by default, set it to 1. Okay, remember these integrations are not absolute values, so that does not mean it's 1 proton. It just means in terms of a ratio. So if I go over here to the BH3, I can select that. Okay, you can see within reason, that's about a 1-to-1. That corresponds to 3 protons apiece. I can save that. And then what you can do is if you need to download this, there's one of the ways that I would do this is if you go to publish, and you go to where it says, now you might be able to copy it and paste it right into um, uh, your word processor. So that's one option. You can also save it as a PDF or a PNG. I often will save it as a PNG and then I'll insert it into my document as a picture. But again, there's several options. Okay, so that's how you would process a proton spectrum. I'm going to pull up now the boron spectrum. Okay, and you look at that, that looks a bit of a mess. One of the things that happens with the boron NMR is that it will, because we get interference from the borosilicate glass, it has a hard time of manual or automatically processing the spectrum. This peak over here, right? This is actually the peak that we're interested in. This right here is due to some interference from the borosilicate glass. So one thing that you'll have to do with boron that you typically don't have to do for proton or phosphorus is you'll have to phase the spectrum first. So if I go back to process, I can click on adjust phase. And what it's going to do here is it selects usually the most prominent peak, and you can use these different features, these different types of corrections. Generally, if you just use a zero order correction, and what I'm going to do is I'm going to click and hold, and then I'm going to drag. Okay, and if I drag up, okay, it's coming off my window a little bit, so I might have to zoom out. Let's see if I can move it down a little bit. Okay, so I might have to zoom out. The other thing that I could try to do is, well, I'll start there. So I've got now I've got the peak going in the right direction. Oops. Right, and like I said, you can do some of these other types of corrections as well. But really the zero order correction just gives us that in the positive direction. As you saw, I could use this to sort of move things around so I can see this a little bit better. So I can do that. I can try to do a baseline correction. That may or may not work. It all depends. But if I do correct baseline, I can do it manually, but I can also try automatic and see what happens here. And that looks a lot better. So we can use an automatic baseline correction. So the way, again, the way I did that is I wanted to advance, and I went to baseline, correct baseline, and I used the automatic function here. So anyway, and that's generally about as good as it's going to get for a boron NMR just because of that interference. There's really nothing to integrate here. If you had an impurity, you might try to integrate them. But really, this is what we're looking at. Now, you see that the phasing is still not great. Should be a quartet, a 4-line pattern. So you can see here, 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 and here. If you needed to get the coupling constant, so when we have multiplets, we often want the coupling constants. The way that you would do that is you can do it actually two different ways. One, I can go through and pick the peaks. So if I pick the peaks, as we did before, okay, you can see it selects them. Between any of these maxima, okay, that's going to be your coupling. And what you can do is you can just take the ppm shift difference and you can multiply that by whatever the Lamar frequency is of that nucleus, and that will give you the hertz. Or what I can do is if I click here, I want to make sure actually I'm not selecting anything. I click here and I click and drag, it'll tell me the distance. And so here it's showing up as 90.5 hertz. So that's how I can record. And a lot of times that might be easier is if you want coupling constants for your multiplets, so your doublets, triplets, quartets, you might do that is just click and drag between the two peaks, and that's going to give you the coupling constants that you're going to report in hertz. Now boron, what we do in our classes, we're not using an internal or external standard for referencing the peak shifts. Generally, the NMR spectrometer does a pretty good job of getting pretty close to those peaks anyway. So there's no peak referencing that we're going to do here for boron, at least for the course. So anyway, that would be for the boron NMR. Now, there are times that you might actually, we have phosphorus. Um, phosphorus would be processed a similar way. With the phosphorus NMR, though, the phasing should be fine. You shouldn't have to worry about the phasing for that. But like like boron, phosphorus, I'm not going to have us use an internal or external reference for the shift. Um, there is a way through the program where it will apply um, the reference for the proton NMR, and it'll apply that correction to the heteronuclear NMR. So we could, if the peaks are quite a bit of ways off from what they should be, we can go through and do that um, while processing. But like I said, generally for boron and phosphorus, we'll generally go with what the NMR gives us based on its default processing rather than referencing it on our own. So that should be about it in terms of the TopSpin and how to use it. Like I said, if there's another program, free program that you found, you don't have to use this program, but this generally works pretty well. So make sure we save our results. You can go through and then just like with the proton spectrum, you can publish it and save it as a PNG if you'd like, so that you can insert it into your lab report. Well, if you have any questions about using TopSpin or processing NMR spectra, don't hesitate to reach out.